Number 19, you're writing formulas for ionic compounds. Let's go ahead and get started. So there are certain ions that you need to have memorized, certain groups. So for instance, group 1 is going to form a positive 1 ion. Group 2 is going to form a positive 2 ion. Just aluminum is going to form positive 3. Everything else you either have to memorize or figure it out. Group 17 down to astatine is going to be negative 1. Group 16 down to tellurium is going to be negative 2. And group 15 down to arsenic is going to be negative 3. Okay, and again, everything else you either have to figure it out by what it's combined with or you have to have it memorized. There's other ways to figure it out too. So let's go ahead and write some formulas. Here we're going to take the sodium ion and the iodide ion, and they are going to bond, and so that's going to form sodium iodide in Ai. It has to be neutral. We usually talk about, for these, drop and swap. We take the charge here, so this is +1, this is -1, we just don't write the ones. We take the 1 and put it here for the iodide. We take the 1 and put it here for the sodium. But remember, they have to add up to be 0. So sodium, positive 1, and iodide, -1 equals 0. Okay? So here we look at calcium fluoride. If we do the drop and swap method, the 2 comes down here, the 1 goes down there, and we get the formula CaF2. But remember, it has to be neutral. So here's calcium 2+, here's fluoride. Is that neutral? No, that has a positive 1 charge, because a positive 2 and a negative 1 is going to equal positive 1. So I need 1 more fluoride. So that's how I end up with 1 calcium and 2 fluorides. Okay? So here's the magnesium ion and the sulfide ion. So magnesium ion, let's see, magnesium is right here. So it must be a +2. So I'm going to write that it's Mg2+. And sulfide is right here. Okay, that's the sulfur ion, so it must be 2-, so S2-. So a 2+ and a 2- are already neutral, so my formula ends up being Mgs. Okay, the aluminum ion is right here, so it's +3. The oxide ion is 2-, so if we look at the periodic table, it's right here for the 2-. Okay, if I do the drop and swap, so in other words, the 2 goes over here, the 3 goes over there, so I end up with Al2O3. No charges in a compound. Okay, it's neutral, it's not 2+ and 3-, it's 2 and 3.